On our 2.7 and 2.8 notes, we will try to combine functions. Let f of x be 1 over x minus 2 and g of x be square root of x. And we will try to find each and every one of these functions, domains, and let's start by combining the function if we can. For the first one, we're looking for f plus g. To find f plus g is literally 1 over x minus 2 plus square root of x. Now, just like we combine the domain here, we will have to also combine both domains. You already know how to find the domain of 1 over x minus 2. You know how to find the domain of square root of x. So I will go back first and the domain of f of x. The domain of f of x are all real numbers except 2. So it's from negative infinity till 2 with a parenthesis at 2, union 2 till infinity. And the domain for g of x is all real numbers greater or equal to 0, or I will say from 0 till infinity, this time with a bracket. Because here you will say x is greater or equal than 0, and here you will say x minus 2 is not equal to 0. Now, to find the domain of f plus g of x, we need to combine these two domains. By combining these two domains, well, we will find the intersection between the domain of f and the domain of g. If you can picture the intersection, that would be great. If you cannot picture the intersection, I suggest you start with a number line. Let's go ahead and represent in red the domain of f of x, meaning I will go ahead and mark 2. 2 is somewhere here, and apparently it's an open circle. I just put a closed one. So this is open, and that's at 2. And we want everything from this side and also this side, of course not including 2. The domain of g, on the other hand, I will represent it in blue, is from 0, included at 0, all the way till infinity, meaning going this side. The intersection where we have both blue and red will therefore be from 0 all the way till 2, bracket at 0, parenthesis at 2, union, because it's not included at 2 for the red one, union 2 till infinity. And this one will be the domain of f plus g of x. Let's do the same thing for f minus g of x. I will have 1 over x minus 2 plus square root of x. Well, it won't change much in the domain. It will stay the same. The domain for this will be the same as this one. For f times g, it will be 1 over x minus 2 that I'm multiplying by square root of x. Once again, the domain will not change. The domain will be the same as this, same domain. So all these three have the same domain. Now for f of x over f of g, that will be square root of x, that's f of x. Actually, square root of x is g of x. So f of x over f of g, what I will do is I'll go ahead and start by writing f of x, meaning 1 over x minus 2 over g of x. G of x is square root of x. Of course, it's over 1. If I use the keep change flip, I will end up with 1 over x minus 2 times 1 over square root of x, which is equal to 1 over square root of x times x minus 2. Now the domain will be different. It will still have the same restriction as for f and for g, but on top of that domain, we will not include 0. So if I want to represent this graph here, it will be the same thing as what I did earlier. Start with a number line. The domain of f now is still from 2. I will represent 2 with an open circle. It's taking both ways, of course not including 2. But the domain for g, the fact that g is now on the bottom, it will start from 0, and it will also be a circle at 0, and it will be going only one direction. So the new domain will be from 0 all the way to 2, union 2 till infinity. The only difference is that it's not included at 0 anymore. For E, it says find f plus g of 4. To find f plus g of 4, you literally have to plug in 4 in the function of f and 4 in the function of g. So this is f of 4 plus g of 4. And to find f of 4 plus g of 4, that will be 1/2 plus 2, which is equal to 2.5 of 5/2. Or you can also say 2.5, it doesn't matter. I just don't like mixed numeral. Number 2 says let f of x equals x squared, g of x equals x minus 3, find each of the following. This time we have a composition of function. We say f of g of x. Since we're looking for f of g of x, the first thing you have to do is the inside of the parenthesis, g of x. After g of x, we plug in g of x into the function of f. So f of g of x will be the same thing as f of, what is g of x? It is x minus 3. Now in the function f, I replace each x value by x minus 3, and now we end up with x minus 3, the whole thing squared. And of course, this is good enough. If you want, you take it one step further and say it's x squared minus 6x plus 9. For the function g of f of x, on the other hand, I will plug in f of x into g. So I will look for g of f of x, which is x squared, and I will plug now this x squared into this g function, and this one will be equal to x squared minus 3. Let's go ahead and move on to the next portion. The domain of f of g of x is the intersection of the domain of g of x and f of g of x. Very important. It's no longer just for f of g, but for g of x and f of g of x. So let f of x equals square root of x and g of x equals this. And we want the domain of g of f of x. The first thing I will do is find the domain of f of x. Well, the domain of f of x is from 0 till infinity, bracket at 0. Now let's find the domain of g of x. The domain of g of x would be all the values. You will start by saying 2 minus, you will say 2 minus x must be greater or equal to 0. If you move the x to this side, you end up with 2 is greater or equal than x. Now that we have 2 is greater or equal than x, by the way, we're looking for f of g of x, or no, we're looking for g of f of x, so we don't really need g of x. This is intersection. It will be the intersection of f of x and g of f of x. So what I can do is find g of f of x instead. So instead of finding this, I misread it. I thought it was f of g of x. So instead of finding this, I will go ahead and look for g of f of x, which is g of f of x is square root of x, which is equal to square root of 2 minus square root of x. Now that I have this, I'll go ahead and find the domain of this. First domain inside the radical is all the x values that must be bigger than 0. But the domain of the whole thing, I would say 2 minus square root of x must be greater or equal than 0. Or 2 must be greater or equal than square root of x. Square both sides. If 2 is greater than square root of x, I can square both sides to say 4 is therefore greater or equal than x. Now, let's go ahead and combine the two domains. Here's my number line. The domain of g of x says that it starts at 0, is including 0, and it goes all the way till infinity. The domain of g of f of x, which is this function, it starts at 4, which is here. By the way, this is 0 and this is 4. It starts at 4 and it goes the opposite way. So the domain of the intersection between both will therefore be from 0 all waiting for bracket on both. If h of x is equal to the fourth root of x plus 9, find f and g such that h of x is f of g of x. Well, the first thing I will say is this one represents your result, and these are the you want two functions that will resolve with this after you use the composition. I will start with f of x. F of x will be equal to the fourth root of x, why not? And g of x will be x plus 9. Note that g of x is the inside function, f of x is the outside function. So the inside remains the inside and the outside is the outside. That's one way of looking at it. For number 5, it says if h of x is equal to this, find f and g such that f of g of x. Once again, the inside function is g of x. So in this function, it's a rational function. So the inside of the rational function is the denominator. So I will say g of x is therefore equal to my inside, which is x squared minus 8, and f of x will just be 5 over x. Alright, let's keep going. This time we're getting to our 2.8 inverse function. For 2.8, it says if f of x has a domain A and range B, then the inverse function of f has domain B and A. The graph of the inverse function x is a reflection of f of x across the y-axis. I mean the y equals x, not the y-axis. And if f and g are inverse of each other, I want to highlight a few things. If f of g are inverse of each other, then f of g of x is equal to x and g of f of x equals x. So if they inverse, f of g of x equals x and g of f of x is also equal to x. Let's practice this. The graph is said to be one-to-one if there are no overlapping or no repeating x value. If f of x is one-to-one, then the inverse of f of x is also a function. Let's start with 4. I feel like I skipped something. Let's check. Oh yes, I skipped something. Let's go ahead and do this first. F of 1 is equal to 5, f of 3 is equal to 7, and f of 8 is equal to negative 10. Find the inverse of 7. Well, the inverse of 7 will be 3. If f of 3 is 7, the inverse of 7 is 3. If f of 1 is 5, the inverse of 5 is just 1. Find the inverse of f of x. To find the inverse of a function, you will replace the x values. By the way, this is the same thing as y is equal to x to the power of 5 minus 3 over 2. The first thing you do when you have such a function is to replace your y value by x and replace your x value by y. And from here, all you have to do is solve for y. So if I cross multiply, I get 2x is equal to y to the power of 5 minus 3. Then I will add 3 to both sides to say y to the power of 5 is equal to 2x plus 3. And from here, all I have to do is use the fifth root on both sides to get y is equal to the fifth root of 2x plus 3. And that's your inverse function of x. You learned this a while ago. All you have to do is switch your x and y and you can find the inverse function. Find the inverse function of f of x. Once again, I will switch it to x equals square root of y minus 2. And I will square both sides to get x squared is equal to y minus 2. And I add 2 to both sides to get y is equal to x squared plus 2. Well, our inverse function of x is x squared plus 2. But there's a little condition. for all the x's that must be greater or equal to 0, because at this point I can say x is greater or equal to 0 based on this. Alright, going back to the page that I was on a minute ago. If f of x is 1 to 1, then f inverse of x is also a function. If the graph of f of x at the right 1 to 1, is the graph of f of x at the right 1 to 1. Alright, let's go ahead and look at it. To be 1 to 1, the inverse must also be a function. In other words, if I flip the x and y, it will still be a function. No longer checking for the vertical line test, I will check with the horizontal line, because if it's a function vertically, it should also be a function horizontally if it's 1 to 1. So this one is hitting at more than one point, meaning it's a no here. Is f of x a function? Yes, f of x is definitely a function because it will pass all vertical line tests. Is the inverse of x a function? I would say no. So the only way that it will be 1 to 1 is if they're both a function. I believe this is it.